I'm happy to have Hank Landsberg with us from Henry Engineering. Hank has been a broadcast engineer for, you don't want to say how long, do you, Hank?
Many years.
Many years, donkey's years. And he is, of course, the maker of a number of little products that have made life simpler for you and me over the years. So we'll turn it over to you and let's talk about power considerations and why it's important to think about them and to be proactive before the power strike hits.
Right. Okay. Well, thank you. Thank you for inviting me here this morning. Um, you you mentioned I had been in the broadcast business for many years. Here's the first station that I worked at. How many of you had one of these?
That's not cheese radio, is it?
No, this is predates Cheese Radio by many years. This is from KHGL 860 on your AM dial, the famous night kit broadcaster from Allied Radio, $11.95, and it includes a phono preamp. So what better deal can you get?
How about the Matchbox? Is the Matchbox included?
Yeah, no, that had to wait about 20 years for that to happen. Anyway, yeah, we on the sign, excuse me, on the sign controls side of things, we've been making power clamp units, which are cool. Um, we've been making the power clamp surge suppressors. They've actually been in production since the late 70s, when the original company started producing them. The company started when it was called Sign Control International. It was started by a couple of guys who um, designed the original product for the military. They needed a thing to get rid of spikes and surges on the power line at bombing test ranges. This was back in probably the mid to late 70s. And so then it evolved from that. And the original owner of the company, a guy by the name of Tom Rivera, he wanted to, um, 20 years ago, at the suggestion of a good friend of mine, was chief engineer at Univision here in LA. And he was telling me about these really good surge suppressors that work so much better than anything else he had tried. So I got sort of hooked up with Tom Rivera, and they had a really nice, really well-designed product, but they had never marketed them to the broadcast industry. So that's when I got involved, and I started taking his product, marketing it to the broadcast industry. And then about, I don't know, 10 years after that, he decided he wanted to retire. So that's when I bought the company from him. And over the course of the last 6, 7 years, I redesigned the packaging of the product, but I didn't change the electrical design because the electrical design worked just great, just the way it was. I just sort of updated the production technology so it would be. I was able to reduce the prices somewhat and so on. But anyway, so I'll talk a little bit about um, what makes it unique and basically how it works. Um, the whole idea of a surge suppressor, of course, is to get rid of transient spikes and surges that come down the AC power line. And turns out that's not as easy as you think. Um, because power line surges and spikes, well, they pretty much come in two flavors, depending on what causes them. You have the most common, well, I won't say the most common, the most dangerous, you would think, are spikes that are caused by lightning. When either the power line takes a direct lightning hit, which really doesn't happen all that often, but much more frequently what happens is there's a lightning storm in the vicinity, which then induces a voltage spike into the power line. Uh, the power line being a really effective antenna for soaking up electromagnetic radiation that comes from lightning. So when that happens, what you get is a very high amplitude or tens of thousands of volts on your power line. But luckily, the pulse width is generally very, we're talking microseconds or a couple of microseconds, just because lightning is a very fast natural phenomena. So you may get a spike of a few thousand volts or maybe more than a few thousand volts, but luckily it's a very short-term spike. On the other of spikes and surges on your power line is other users on the grid. In a lot of cases, like at a transmitter site, your site is at the end of who knows how many miles of power line, maybe a mile down the line or 10 miles down the line. There's other customers drawing power from that same circuit. And if they are kind of industrial users, business users, equipment that like heavy motors or anything that's inductive, like a welding shop or a auto body shop or a commercial printer, commercial laundry, a hospital, any of those kind of users that use a lot of energy but are constantly switching things on and off. All that switching and motors starting up and shutting down and air conditioning units starting up and shutting down and so on. That produces surges and spikes on the line. Those are much lower level in amplitude. They may be only 50 to a couple of hundred volts, maybe up to 500-600 volts. But it's a much wider pulse width. Instead of microseconds, we're talking milliseconds or maybe tens of milliseconds or even more. And those, even though they're not nearly as high in amplitude, they are wider, and they happen much more frequently. They happen pretty much throughout the day, maybe less at night when a lot of businesses shut down, but even so, those kind of things can happen hundreds of times every. And if you've ever put in a solid state transmitter, especially one that uses a switching power supply, you know how susceptible any kind of power line disturbance. So anyway, so what we do, I'll show you a couple of examples of power clamp, and a lot of you may have seen this already, but the power clamp units come in kind of in two sizes, two flavors. The big one, which is what we recommend for transmitter sites, and a smaller one. And the only difference between the two is the surge amp capacity, how much of a surge they can soak up. The smaller one is rated at 80,000 surge amps. Surge amps defined as a very short duration surge. So the small one's rated at 80,000, and the big one is rated at 200. So there's a big difference between the two. But they both work, idea. So we have two different kinds of surges. We have a lightning induced, which is very high amplitude, but very short duration. And then the opposite of that, where we have other customers on the grid causing spikes, which are only maybe a few hundred volts, but wider pulse width. A lot of surge suppressors use just MOVs, metal oxide varistors. That's what you find in your typical cheap plug strip that you get at Home Depot. Even if you use a lot of MOVs, the problem with MOVs, and I'll try to do a screen share here. It would be nice if MOVs worked like this, where at a certain point of rising input voltage, the MOV would suddenly turn on and start conducting, just like a clipper, like an audio clipper.
You're still showing us just the file?
Oh, you're not seeing the actual,
No.
that's weird. I'm seeing it here.
Could it be on a different screen?
All right, well, instead of this,
While you're doing that, I'll just mention to those who've joined us recently here, Hank's got a little bit of an internet a glitch down there, and that's where the hiccups are coming from.
oh, okay, I'll do it the analog way. This always works. It would be great if MOVs worked like this. You know, as when you got to a certain input voltage, the MOV would suddenly turn on and start to conduct. That would make life very easy. But unfortunately, they don't work like this. A sloppy compressor. They start to conduct at some point, like where you see the number 1 there. And then as the input voltage rises, they start to conduct more and more. Conducting is not very well defined. It's, as I said, a rather lazy, sloppy, and this makes life difficult because if you use just MOVs in a surge suppressor, down to set your conduction threshold around here so that it's going to catch stuff that's only maybe 50 or 100 volts above normal voltage. It's going to be conducting pretty much all the time, even when there's no surge. And that constant small amount of conduction causes heat within the MOV, and it gradually burns away the metal oxide material, and it causes the conduction threshold to gradually rise. So after that thing has been plugged in for 6 months or a year, it becomes rather ineffective because the conduction threshold is now so high that it's not doing any good. On the other hand, if you set the conduction threshold up here so that it's not conducting with normal voltage, well, then it ignores everything, between the 2 points. And it only responds to really high voltage spikes, but it ignores the 50 to 100 volt spikes that happen all the time. So it's not a one size fits all kind of a thing. So what we do in the power clamp design is that we have 2 separate circuits that are independent of each other. We have MOVs, which handle the lightning induced stuff, and we set the MOV threshold high enough so they only respond when the spike gets to be, way up there, at least 1,000 volts above normal. But we set it high enough so that it's not conducting with normal line voltage, so it doesn't degrade the MOVs. They can sit there for 10 or 20 years and they're still just as effective as when they were new. But then what do we do for all those lower amplitude spikes? Well, that's a separate circuit. So we have these two circuits that are in parallel with each other, and they're both shunting spikes to ground. Power clamp is a parallel installed device. So whenever you do get a spike, it conducts to ground and sends that spike to earth ground. So we have the second circuit, which is the secret sauce. If we open one of these up and take a look, I think you can see this. If you look at the top, you might be able to see it. You'll see a bunch of MOVs up there. Those are the things that take care of the very high voltage spikes caused by lightning. And then on the bottom, you see that thing with the square white label. That is the secondary low voltage suppressor, and it responds primarily to longer duration disturbances. A lightning spike of a couple of microseconds, it won't even see it. But when you get into stuff that's in the millisecond or tens of milliseconds range, that's when that other circuit kicks in. And what it does is it maintains a very low clamping level for those wider duration spikes. What that circuit does is it looks for the peak of the sine wave, and that becomes its reference level, the peak of the sine wave of your normal voltage. So as your line voltage will change throughout the day. It usually kind of sags during the middle of the day, and it may go up a bit at night. Well, it just fixes on whatever that peak voltage is. That becomes its reference. And then anything that's more than about 10 volts above that gets clamped. And low voltage surge suppression network. So by using two different circuits, one for high voltage stuff, one for lower voltage wide duration stuff, we're able to get rid of just about everything nasty that's coming down the power line. So that's the basis of how it works. Did you do that?
Yes.
Oh, okay. Well, good. Well, that makes life easy. So that there you can see that the Series 200 is the bigger of the two, and then the Series 80 is the smaller one. Series 80 is fine for a downstream installation. Hopefully you have a bigger unit upstream. The best place to put these things is as close to the main panel as you can get them. Because as I said, these are operating in parallel with your incoming power service ground. So the lower the ground impedance, the more effective the unit is. So your main panel, that's generally where your neutral and ground wires are tied together, and that's where you have a direct connection to earth ground. So that's the best place to put it. And that's kind of, you can see over on the right, a couple of strip chart recordings that were sent to us by a client. This was a hospital here in many years ago, but you can see all the weird junk that was on their power line as a result of MRI scanners and other medical equipment that uses horrendous amounts of power. And when they put in the power clamp unit and ran the same test, you can see that it just all the spikes and surges and whatnot all just went away. That's a good example of lower voltage but wider duration spikes caused by things turning on and off throughout their facility. So so we make power clamp units for single phase and three-phase Y and delta, although that's not really used very much anymore. All the usual, 280, 277, 480, 120, 240, 208 voltages that are used. So basically, you just install the thing, wire it up to a breaker on the panel. If you have space, you put in a 15 amp breaker. The power clamp units are all fused, so if the thing overloads and something goes wrong, like an MOV shorts or something, but it won't take your transmitter off the air because they're installed in parallel, not in series. So there's no voltage loss through the unit, and there's no need to match the load current with the power clamp. Power clamp doesn't care whether you got a 100-watt transmitter or a 50 kilowatt transmitter, doesn't make any difference. So that's the story on power clamp and what makes it unique. Typically, most we'll say grid created spikes and surges will be clamped to 10 volts of lightning spikes will be higher, but they'll be brought down to maybe within a couple of 100 volts of the peak of the sine wave. And then the secondary circuit will kind of take over and bring them down a little bit farther. So bottom line is this product is the proverbial ounce of prevention that's especially when it comes to solid state transmitters and their nasty habit of blowing up power supplies.
Hank, let me ask a question then. You talk about this being in parallel. Is there an alarm circuit here to let the user know when one of these fuses goes out?
Yeah, there is. In fact, if you look, well, let's see, we had it on the graphic that you had a minute ago. Yeah, there's relays. You can get a relay option that will let you know. There we go. If you look at the series 200 up here at the top, you see these three white things. Those are relays. So if any of these fuses down here blows, one of those relays will open up and give you a contact closure, which you can interface to your transmitter remote control and give you some kind of an alert back at the studio that you've lost a fuse. If you look carefully, it's kind of hard to see, but there's three LEDs here, and those light up over there. You'll see them over here. Those will light up to tell you which fuse needs to be replaced. So yeah, there you can see the relays up there.
All right, good. Anyone have a question for Hank at this point? Press your space bar, alternate A. Anything you'd like to know about power and spikes and
No
what we
questions. I think that's good. I can go run out and get a backups unit if you want me to talk about that quickly.
Sure.
Okay, hang on just one
I
second.
think it would be a good idea.
Yeah.
What we're talking about is a product that Hank came out with a couple of years ago, and that has to do with the UPS issue, because all of us, I think all of us, will agree that having a UPS on your critical mission equipment is important. And so what you want to know is that, well, if the power dies, it's going to continue. It's going to stay up and running. But batteries do die and systems do break down. And so here's the point. You want to know when that happens. And then what do you do? Hank?
Okay. So a couple of years ago, I had a couple of the LA area engineers ask me about if I had a thing that did this. And since I didn't, I decided I should. So anyway, we came out with this product called Backups. And it's a plastic box thing that has its purpose is to automatically bypass a failing UPS. UPSs have batteries in them, of course, and very often when the batteries get weak, the UPS will start doing weird things. It will shut off and then come back on, and shut off and come back on. And the problem is if you have a UPS essentially in series with your AC, once you have it installed, if you need to change the battery on it, you can't, if you remove the UPS from the circuit, your rack full of equipment goes down. You can't, you can't service the UPS when it's plugged in, or you probably shouldn't. So what this does is it bypasses the UPS when it starts to get flaky. You'll see we have two AC inputs. One comes from the output of the is plugged directly into a wall outlet. And on the back side, we have a, duplex outlet. So the way this works is when the UPS is working and everything is fine, the power from the UPS gets routed through this box straight to the output. Straight through, doesn't make any changes. But it's always monitoring the output of that UPS. So if its voltage drops, this unit immediately bypasses it and switches to direct power, direct from your AC. The power comes back on from the UPS. It doesn't switch over to the UPS instantly. I don't think you can see this, but we have on the front here a dip switch right under there. No, over there. There's a dip switch. And by setting those dip switches, you can program a restart delay time period so that when the UPS comes back on, it waits and it monitors the UPS output to be sure it's stable before putting the UPS back online. So that prevents the thing from going back online if the output becomes unstable. Oh, cool. You got one installed there. Very good. Nice.
Oh, you guys actually see that? I was just trying to prepare.
Oh, no, I'm seeing it, so it looks good to me.
Heck, I've been running this for 4 years. I've never
Oh.
heard a glitch on my stream.
Oh, good. Cool. Excellent. So that's what the backups does. It backs up your UPS power supply. So if you have any problems with it, or if it senses problems with it, it'll bypass it. And of course, once it's bypassed, then you can unplug it. Your rack stays live. Everything stays on the air. And then you can, there we go. Then you can replace the batteries in it and fix it or do whatever you got to do. You can see in the photo over here, that's where you set up the delay time. You can also remotely control this unit. You can put these up at a transmitter site. So if necessary, you can force bypass a UPS that has gotten flaky. If you see that that the backups unit is constantly bypassing it putting it back online, bypassing it, putting it back online, bypassing it, then you know you got a problem. But if you're not going to be able to get up to the transmitter site for a few days, you can remotely force the backups unit to permanently bypass the UPS so it doesn't sit there and switch back and forth and back and forth. So that'll, give you time to get up there and change the batteries or do whatever you've got to do. So it's a pretty simple device. We've sold a lot of them, and they work really well. Any questions on that?
Yeah, Hank, it's Mike. I have a question. Most of my UPSs are larger and use like L53 connectors for power.
Right.
Are you considering something a little more beefy than that little guy?
Maybe.
Rack, like one UPS per rack.
Yeah. Is it
you blanked out there.
Oh, are they 240-volt UPSs?
No, they're 120, but they're 30 amp.
Oh, okay.
So they have the L530 connector, the twist lock.
Right.
Here, I can show you. I don't know how. Can I share, Barry?
Yep.
Right, but
All
I
right,
could.
let me just look at here. Share screen. That guy.
Let me look into that. It might not be that big of a deal to. So that's standard 120 volts, 30 amps, right? Yeah. The relay in this unit is good for 15 amps, so we'd have to go to a bigger relay. But
exactly right.
But other than that, the basic circuitry would stay the same. I can look into that.
Just a thought.
Hard to do. Yeah, we did make a 240-volt version for use in Australia, but that still uses the same IEC connector that we have on here.
Right.
So that didn't take very much of a change. But
and of course, for me to use that, I've got to wire up another L530, plug or socket.
Right.
Which means my electrician's got to get involved, which means it's a little harder to implement than just, plug in like with the unit you have there.
Right.
Yeah. Okay, just throwing it out there.
It shouldn't be a big deal. This one was made, for the smaller UPSs, but a rack mountable version with a big fat relay in it would probably be a good idea. So thank you for that. I'll look into it and I'll let you know.
Hank, I'd like to tell you about, I think all I know for sure, I sold 2 of your units for a non-broadcast application, and maybe more than that because there was a fellow on the board of directors at the water company that I'm part of. He liked what he saw, and I think he bought some. But anyway, here where I live, we have the La Cañada Irrigation District, and this is before I was on the board of directors. Maybe it got me on the board of directors, I don't know. But one day, Southern California Edison decided to replace a power pole out behind the office headquarters for the water company. Now, inside the building there, they have a SCADA system that is controlling all the pumps at the reservoirs, bringing back data and keeping the reservoirs at the right level. Well, what happened this day was Southern California Edison killed the power while they were replacing the power pole. Then the UPS took over and ran for several hours until its battery died, and then the SCADA system died, but the pumps kept going and water's running down the streets. And one of the reservoirs near me, I wondered, why is all this water coming down the street? So I called the water company and they sent somebody up to shut things down manually. And when I met with the manager and found out what was going on, I said, there's a good solution to this, is one of your backups. So the water company bought 2 of them, and now they've got them on 2 of their computers there that are involved with the SCADA system to prevent that from happening. So it's working out well for us.
Good. Good. Glad to hear.
I've got a question. It's a bit historic. You mentioned three-phase rural power. This was 100 kilowatt FM in Rolla, Missouri, but the transmitter was halfway to Salem going south. Talk about really, really rural. And we'd single phase all the time because somebody knocked one of them out, either by an auto accident or something on the farm and so forth. And we had this. This is way back. This is a dual 10 H3 Harris transmitter with tetrodes. And what would happen depending on what got knocked out, we had the automatic power controls on it, which I ended up disabling. It was the screen voltage that would try to compensate for the missing phase. And we noticed the power was really down. And then when the third phase came back, pow, it would all trip off and we'd have to go down there. Do you have any equipment, or is it even necessary anymore with modern day transmitters for compensating for single phasing?
You mean to compensate to?
If you lose a phase on a three-phase feed.
Oh,
Now, also, by the way, the 110 volt racks are on one of the three phases. You know,
yeah,
if it depends on which phase you lose, those could go down.
yeah. You could, yeah. Everything could go down if you.
Yeah. So I wonder if you run into that pickle.
No, I haven't.
I'll tell you my solution.
There's three-phase converters that people have used. What did you do?
Well, we had an amateur radio repeater on site that had batteries, and it also was hanging on one of the 110 legs. And if something would happen strange down there, you could thump the repeater, and it would Morse code battery on the end of the ID, so you could tell that phase was down. All right, so that was valuable, however illegal, I guess. But my next job was at Mosley Associates, and that led to the TRL1, the telemetry return link. By the way, our telemetry return on that FM was subaudible SCA. This is in the 70s. You probably haven't had such joy. But the TRL1, which is a little 450 data link, I don't know if they still sell that or not. There's a room for that in the 450 FCC rules. And if the power was lost to the TRL1, it also Morse code identified and would say battery on the end of it. So just by listening to what was going on, you could save yourself a trip to the 12-mile away transmitter. And your gadgets there remind me of a lot of whatabouts.
That's an interesting way to go about it. Thank you.
One other thing, I did a lot of work when I was at Scientific Atlanta with the Turner Teleport downtown Atlanta, and they had to put up a little tower and put a channel 17 backup on so they could stay on the satellite. And that thing turned into be quite a lightning rod. Okay, it was upsetting everything down there. And so I suggested to them some LEA lightning arrestor fuzzballs and stuff, and they had a pylon on top of that. And of course, the chief engineer there said, well, they don't make one for a pylon, but they do. He didn't know it. They had never used systems like this. So actually, we didn't resell LEA equipment, but I linked them both together, and then they got real interested with LEA's suggestion with harmonic suppression in the power lines, pi filters, which they then put on all of their buildings and all the playback stuff down there on Techwood. And that really helped a whole lot to suppress the ringing of the lightning strikes. And it didn't have to be direct. Stuff could be, 10 miles away. What they do when I left is they'd start up all the generators when they saw if there was thunderstorms inside the perimeter highway there. But do you have any of those filters that you would, like LEA did, that you could put in feeding the equipment for also ringing suppression?
No, I don't. That's a whole other animal.
By the way, the guy wanted references if any LEA protection equipment was anywhere in the Atlanta area. I forget the guy I was working for. They were in Southern California. I think they're still in business. But the biggest user in Atlanta of LEA lightning suppression equipment was the airport.
Probably, yeah.
They're all over the place on all
Yeah.
the concourses.
Yeah, we have a
Huge
lot.
user.
we
Yeah,
have
and
a lot of
it really solves some problems.
Yeah, yeah, we have a lot of airports use
Yeah.
power clamp stuff.
So fun stuff. Thanks for reminding me of my boyhood.
I see Pierre Lone Wolf is up on the screen. I think we many years ago I had another business doing CD music libraries. I think I actually visited KOTZ up in Kotzebue. Are you still there? Okay, you're muted.
Yes, I am.
Okay.
1 years and some change so far, and I'll probably die under a console or something.
I just wanted to say hi.
Yeah, nice to see you
Been a
again.
long time.
It's been that was a long time ago.
Yeah, early 90s, I think. Yeah.
Yep, it was.
Yeah.
Yeah.
Yep.
And let's see, I managed to save that library. Was it Hellland or?
Howland, yeah, Howland, yeah.
Yeah.
I was the
Got
land.
Hellland.
Yeah, I was the land of Holland.
Yeah,
I still have a KOTZ t-shirt somewhere.
Hey, I'll send you another. Got better designing them.
Okay, the other product I'll mention, and I don't have one to show you, is another thing that not many people know about. It's a power line monitor, just a voltage monitor. It's an easy way of monitoring AC voltage levels at your transmitter site. And it's in a box the same size as one of these. It has 3 custom transformers inside, and you can monitor 3-phase power just with one box. It'll monitor all 3 phases, and it'll give you a proportional DC output that you can feed into your transmitter remote control, so you can, once you get it calibrated and stuff, you can keep an eye on what your voltage levels up at the transmitter are. And by changing the taps on the transformers, it'll work with 120, 208, 240, 277, 480. So you can monitor pretty much anything, single phase or 3-phase, using one of those boxes. It's called a power tracker, and that's another sign control product.
Does it have a logging feature to let you look back?
No, it just gives you the raw DC output, and that would be done by something else down the line. So you just hook it up to your remote control and calibrate it so that a nominal amount, 5 volts or 10 volts or whatever, DC that comes out of the power tracker, that's your reference. And then you can set your remote control, to give you an alarm if it goes above or below or whatever.
Well, as you said, simple.
Yeah, it's very simple. It's basically 3 wall warts in a box, but more reliable, and special transformer for all those voltages, and 3 phases all in one place. So technically, it's very simple, just essentially just 3 power supplies. But if you need that sort of thing, that's a good way to do it.
Very good. Any more questions for Hank? Yeah,
Not a question, but an attaboy. I installed 5 of your backups units after we had an incident here in the spring of 2023. And I have since put in both a power clamp and a backups at a small non-com that I helped build about a year ago.
Good. Thank you. I appreciate that. I appreciate all you guys that support me and the stuff we make. Everything is made here in California, which is not an easy thing to do these days. But the other thing I like to kind of brag about is the fact that especially on the Henry Engineering side of things, you know, the audio products. As archaic as it sounds, we use through-hole components. All of our ICs are in sockets. So if something blows up, you know, you can swap out a 5532 in about, 30 seconds and you're back in business. So things can be maintained on site. And that's very different from what a lot of manufacturers are doing these days, especially if they're building stuff in China or overseas somewhere. But we try to design products so that not only do they work well, but things happen. We all know that, and it's really good to be able to fix it right on the spot instead of either having to send it back to us or throw it away, because a lot of times parts that are surface mount, either they're nearly impossible to replace, or you end up damaging the board so badly in the process that you end up throwing the thing away anyway. So we try to stay with, sometimes, the old analog ways of doing things, there's a reason for that. So we try to make it, make the engineer's life as easy as we can by making things serviceable when that needs to be done.
So Hank,
Aha.
can you handle two attaboys in a row, or shall I wait?
I'll try. I'll try. From a fellow night kit owner and operator,
Yeah, my dad bought me that when I was 11 years old. I built it. It worked. I took it to school.
Yeah.
I got an A from my science teacher. I took it home and I ran it as a pirate for like 3 years. And when I was 15, I got my first job in commercial radio, and I've never looked back. So if you do the math, I've been in broadcast engineering, not counting the night kit, for 80% of my life.
Yeah, me too. I built this one when I was 11. 1963, and KHGL signed on the air, 860 on your dial. I could hear it for about a block or so. They had a long wire up on top of the house.
Yeah.
I built a little studio with record players, and the first mixer I made. Of course, everything I made when I was a kid was built out of parts that I could get out of old TVs, and the way I would make an audio pots right across the source, whether it was a magnetic phono cartridge or a microphone. I mean, imagine putting a pot right across a microphone. That's when I learned that you can't take the wiper together, because when you turn one off, everything goes away. So that's when I learned about build-out resistors. And to turn the channels on and off, I would use the switches that you could buy at the hardware store, which were like for 110 volt, light switches. And I knew that you had to use shielded cable, but I figured, well, it's much easier to get to the shield than the inner conductor. So for my first mic mixer, to turn the channel on and off, I just switched the shield on and off. I learned in a big hurry that was not the best way to do it. You got a little bit of hum when you turned off the shield.
When I got started, we had a concrete floor, and I discovered pretty quickly that this thing right here has an AC/DC power supply in it, and the power switch on it is in the wrong place, so that if it's turned on and you're in bare feet on a concrete floor and you touch it, if you get a shock, you have to turn the plug over. But then when you turn it off with the power switch, now it will shock you.
Yeah, it'll be worse.
Yeah. But the other thing is I built a mixer exactly the same way, bought some plywood at the local store, got some little pots out of something or other, and I didn't know how to wire them with the build out resistors either. And it was great. But when I finally figured it out, I had this big old plywood box with like 4 knobs and 4 little switches. It was fun, wasn't it?
It was, absolutely.
So the attaboy that I was going to get to is about, God, when was it when the Starlink first came out, the Mosley Starlink STL? It's been a while.
Yeah.
The very first one, the University of Massachusetts Boston got one of those to feed the transmitter site, and we were using our Quincy transmitter site to feed the entire rest of our transmitter network all over eastern Massachusetts. So what would happen was, if we took the AES output of the Mosley, a 1/10 of a second dropout in the data in the Marty would turn into a 2-second audio hole in the audio that the entire network got. And that was when I went back to worshiping analog audio. I took the audio out of the Starlink, even though it was digital in the Starlink, I took it out of the analog connectors and I used that to drive everything that drove the network. And then when I needed AES, I put in one of your 4x1 AES DAs. And that thing has been in there now for more than a decade, and it's probably the most reliable thing in that rack. Thank you.
Oh, thank you. Thank you. That's a good example of what I was just talking about. That DA is truly a DA. It's an analog distribution amplifier, very wide band.
Yeah.
It doesn't do anything with the data. It treats the incoming AES just like a very wideband analog signal. And the chip that we use in there is a military qualified amplifier that was originally used for a video DA. So it has boatloads of bandwidth and 256 or whatever sample rate, and it just, whatever you put in, it makes 4 copies and sends it out on its merry way. So glad to hear that it's working well for you.
Well, it's great because it takes those 1/10 of a second dropouts, and that's all that the listeners hear on all of the other transmitter sites in the network. And it allows me to easily make everything analog in my rack that I want to, because you can't get better than an analog waveform as long as you treat it really nicely. I don't know why anybody would slice a beautiful analog waveform up into 44,100 pancake slices and fling them through the air one at a time with a separate address on them, and at the other end try to stack them back up, glue them together, and then smooth out the edges. I don't get it.
That's the full Benihana.
Yeah. Yeah,
I'm going to
progress. It's progress for you.
I'm going to add to the thoughts here about you, Hank. And I mean, like many others, I've used matchboxes for years. In fact, I used to have 2 of them right here in the home shop, and I lent them out, and they never came back. But everyone should know, I think, and I want to make sure that they do. You guys, Henry Engineering, have been a very big supporter of the BDR. And the fact that you are a supporter of the BDR means that we appreciate that very much and want to thank you for that.
You're very welcome. It's fun. I consider myself very lucky because I suspect a lot like pretty much everybody else here, being in broadcasting, you're basically getting paid to do your hobby. And even though there's, ups and downs and the usual politics and stuff you have to deal with. It's been a very fun ride. Can't complain at all. No
Do you
complaint.
actually have a garage? Or is it really your warehouse?
That's the warehouse. Yeah, I ship everything from here. Yeah, everything is assembled. Our assembly facility is about, and it's pretty simple. When we build a run of product, I order all the parts in. They all come into here, and they all get audited and kitted up and so on. And then the whole kit goes up to the assembly place. They test every unit 100%. We do not just spot check. We test every single unit from start to finish. Then it comes back to me and it goes into the warehouse, which is right outside that door. And so everything ships from Southern California. Pretty simple.
Very
I'm
good.
a big believer in the KISS principle.
Well, here's some contact information for you. If you would like to get in touch with Hank, and he'll walk right out into the warehouse and send it right out to you.
Yep. One-stop shopping. Don't make fun of my AOL email address.
I want to thank you, Hank, for spending the time with us and for not just what you showed us today, but for all that you've been doing over the years.
Thank you. It is my pleasure, and it's been a fun ride, and I'll keep on doing it as long as there's a need for it. So far, so good.